Okay, now let's look at how we're going to go about selecting a WAN technology. So there are several different types of WAN access connections that are available through your internet service provider that they can use to connect the local loop to the enterprise edge. And these WAN access options differ in your technology, the speed that it brings it in, the speed that you need, and especially the cost. Each has distinct advantages and disadvantages, so you need to make sure you understand what is available to you. You have a private WAN infrastructure and a public WAN infrastructure. With the private WAN, the service provider may offer dedicated point-to-point leased lines. It may offer circuit switched links such as your PSTN or your ISDN, and packet switched links such as Ethernet WAN, ATM, or frame relay. And we'll see that here. You have the private, you have the dedicated and switched. We have leased lines. We have your T1, your E1, your T3, your E3. With switched, you got circuit switched with our PSTN and our ISDN, or our packet switched with our Metro Ethernet MPLS and our frame relay and ATM. Or we can have our public WAN infrastructure. And these service providers may offer broadband internet access using digital subscriber lines or your DSLs, cable, satellite. With our broadband connection options, they're typically used to connect small offices and telecommuting employees to a corporate site over the internet. And data traveling between corporate sites over the public WAN should be protected by using a VPN because it's public, so it's not private and not, as secure. Here's one way to look at it. This is the WAN access technologies. Here we have the ISDN, DSL cable. We've got wireless going to this one. Here we have a T1 leased line. Here we have a satellite connection. So there are different types of technologies being used. With our WAN service provider, when it receives data from a client at a site, it must forward the data to the remote site for the final delivery to the recipient. So we need to understand how that's going to work as well. Our service provider networks are very complex. They handle many clients, and they consist mostly of high bandwidth fiber optic media. And using either the synchronous optical network or SONET, or synchronous digital hierarchy, the SDH standard, and these standards define how to transfer the multiple data, the voice, the video traffic over these optical lines or the light emitting diodes, the LEDs, over great distances. One thing to note is that SONET is the American-based ANSI standard, while SDH is the European-based standard. Some of the newer fiber optic media development for long distance or long range communication is called dense wavelength division multiplexing or DWDM, and it multiplies the amount of bandwidth that a single strand of fiber can support. And an example here is shown in this image. DWDM is going to enable bidirectional communication over one strand of fiber. It can multiplex more than 80 different channels of data or wavelengths at a single fiber. Each channel is capable of carrying 10 gigabits of multiplex signal, and it assigns incoming optical signals to specific wavelengths of light, so different frequencies, and it can amplify these wavelengths to boost the signal strength. And it supports both the SONET and the SDH standards. DWDM circuits are used in all modern submarine communication cables, submarine, stuff under the water, and other long haul circuits, as you'll see here. These are the ones that are going, the long distances. Here's an activity for you to check out, see if you understand what's going on. With our private and our public, you can put them in here, you can check them and see if you're right and go from there, just to make sure you've got a good understanding of what's going on in that location. Okay. With our private WAN infrastructure, there's a few things that we need to look at. We have the advantages of our lease line. They include simplicity, because we have point-to-point communication links and they require minimal expertise to install and maintain. We'll let the provider handle it from here into here, and we handle everything inside of our corporate offices. Quality. The point-to-point communication links usually offer high service quality, and if they have adequate, and they should have adequate bandwidth depending on how much you've purchased. The dedicated capacity removes latency or jitter between the endpoints because you're guaranteed that speed. And then availability is constantly available as long as the line is up. Some of the disadvantages are the cost. They can be very expensive to have a T1 or a T3 line in, and it's limited flexibility. Your WAN traffic is often variable. Lease lines have a fixed capacity so that the bandwidth of the line is seldom matches the need expectancy exactly. And any change in your leased line generally requires a site visit by the ISP person to adjust the capacity, and you can just imagine that that in itself is going to cost you as well. Our layer 2 protocol is usually HDLC or PPP. Okay, let's look at Dialup. We have our advantages. It's simple, it's typically available, and it's usually low cost to implement. Our disadvantages are low data rates, or it's slow, and it's relatively long connection time. With ISDNs, here's an example of our ISDN network. We have frame relay. We have ATM. We have our Ethernet WAN. Our ISDN is our integrated service digital network, and it's circuit switching technology that enables the local loop of your PSTN to carry your digital signal. So it allows your phone service to do this. You have your basic rate interface or your primary rate interface. The basic rate has a call setup time that is less than a second. So that's pretty quick. Frame relay is a simple layer 2 non-broadcast multicast, multi-access WAN technology used to interconnect enterprise LANs, and a single router interface can be used to connect to multiple sites using PVCs, and they are used to carry both voice and data traffic. Our ATM, or our asynchronous transfer mode technology, is capable of transferring video, voice, data through private and public networks, and it's built on a cell-based architecture rather than a frame-based architecture. Then we have our Ethernet, and it was originally developed to be a LAN access technology, but we're using it over long distances as well. At the time it was developed, it wasn't suitable for WAN access technology because the maximum cable length supported was only up to 1 kilometer. But now with fiber optic, it is suitable. The benefits of an Ethernet WAN include reduced expenses and administration because you're not having to use the ISP as much. It's easy integration with existing networks, and it's enhanced business productivity. Ethernet WANs have gained in popularity and are now commonly being used to replace the traditional frame relay and ATN WAN lines. We also have our multi-protocol label switching, or our MPLS, and it's a protocol of high-performance WAN technology that directs data from one router to the next, because we will have multiple routers, and it's based on short path labels rather than IP network addresses. There's several defining characteristics. It is multi-protocol, meaning it has the ability to carry any payload, including IPv4, IPv6, Ethernet, ATM, DSL, and frame relay traffic. It uses labels, which tell a router what to do with the packet, and the labels identify paths between distant routers rather than endpoints. It also has a service provider technology. Lease lines delivered bits between sites, and frame relay and Ethernet WAN deliver frames between sites as well. This technology is primarily your service provider's WAN technology. All private WAN technologies discussed so far either are copper or fiber, but we can also use satellite. The very small aperture terminal, or VSAT, is a solution that creates a private WAN using satellite communications. So that is an option. Again, you have another study tool here. If you use public DSL, it's always available. It's always there to you as long as the line is up. You have coax cable. That would be like your cable company. And then you also have your wireless. You have your municipal Wi-Fi, and you also have WiMAX. And then again, the satellite. One of the things that we need to look at when we are creating these large networks that our telecommuters or our remote offices can get to is our security risk. So you do need to include a VPN, or your virtual private network. The benefits of having this VPN are cost savings. They enable organizations to use global internet to connect to their remote offices, and by implementing these VPNs, their information is secure. Like I said, the security, you also have scalability. There's compatibility with broadband technology. There are 3 types of VPNs you can look at. You can look at the site-to-site VPNs, 2 types, or your remote access VPNs. Here is site-to-site, and here is remote, where you would log in and you would key in your username and your password. Again, you have another study guide. Some of the things you need to keep in mind. What's the purpose of your WAN? What's the geographic scope that you're going to need to look at? What is the traffic requirements of your network? And then when you go to select the technology you're going to use, you need to think about, should the WAN use a private or public infrastructure? If you're going to do public, are you going to have your VPN set up? With the private, is it going to be a dedicated or switched? Which connection options are actually available to you locally? Just because you want to use one, it may not be available, so you need to make sure you know what is available in your area. And what's the cost of the available connection options? You have a couple of little labs to do. Okay. And then in summary, you need to think about your business, how it's going to grow, what it's going to need in the future, not just what it needs now. So you're going to constantly need to reevaluate where you are and where you're going. So remember, a business can use a private line or a public. The WAN access standards operate at layer 1 and 2 of the OSI model and are defined and managed by the TIA, EIA, ISO, and IEEE. A WAN may be circuit switched or packet switched. There's a common terminology used to identify the physical components of a WAN connections and who the service provider or the customer and is responsible for switch components. The service provider networks are complex, and the service provider's backbone networks consist primarily of high bandwidth fiber optic media. Permanent dedicated point-to-point connections are provided by using leased lines. Our public infrastructure connections include DSL, cable, wireless, 3G, 4G cellular, and security over public infrastructure connections can be provided using remote access or site-to-site VPNs. Okay, so make sure you get all your labs done for this particular unit and get your exam done, and let me know if you have any questions.